Alright, this last video for the chapter and the last target for the chapter is about the laws of definite and multiple proportions. So this is still dealing with elements and compounds, okay, and we're going to look here with these laws at how we can have lots of different compounds and the percentages that make up a compound and the elements that are in there and what that means. Okay, so we're going to start off with the law of definite proportions, okay, so let's just look at what those words mean. If something is definite, okay, that means always. Okay, always this. That's definite. Okay, if something is the proportion part, means that you're some kind of ratio. Okay, 2 to 3 is a proportion. Same thing as saying 2 to 3 is a ratio. Okay, so we're talking about the law that's dealing with always having the same ratio. When we start looking at compounds, that's then when we get into this always and this ratio, okay? And what the law of definite proportions is, it's a compound, okay, is always composed of the same elements in the same proportions or the same ratios, okay? Because that's what makes that compound what it is. So if we have a different ratio of the two elements, that is a different compound. Okay? If you take, for example, water. Okay, everybody knows that water is H2O. Well, how do I know that water is H2O? Is water always H2O? Yes. Okay, water is always 2 hydrogens to 1 oxygen. Always. Okay, water is never 2 hydrogens to 2 oxygens. It's never 4 hydrogens to 1 oxygen. It's always 2 hydrogens to 1 oxygen, the same ratio, okay, the same proportion. It's also like if I have CH4, okay, this is what we call methane. Methane is always CH4. It's 1 carbon and 4 hydrogens. Always a 1 to 4 ratio between carbon and hydrogen. Okay, so this particular compound that has these particular properties always has the same proportions of elements. Always. Okay, we're going to look at some examples that show this law of definite proportions. Okay, for example, sugar. Okay, so if I have 20 grams of sugar was analyzed, and I see that I have 8.44 grams of carbon, 1.3 grams of hydrogen, and 10.26 grams of oxygen. So I want to see here for sugar what percentage, okay, these elements are, because it should always be the same percentage or the same ratio. So if I've got 20 grams and 8.44 of those are carbon, well, that means that 8.44 divided by 20 is going to give me 0.42. If I want a percentage, I do times 100. So it is 42% carbon. And I look at hydrogen. I have 1.3 grams. Out of the 20 is hydrogen, which is going to be 0.065 times 100, which is 6.5% hydrogen. And then the rest of it, that 10.26 grams of oxygen out of the 20 is 0.513, which is 51.3% oxygen. So sugar, okay, will always be this combination of C, H, and O. Now there are many types of sugars, okay, but the one particular type of sugar that we're looking at has these percentages. Okay, so CHO with these percentages. Now we're going to look and say, okay, if I have sugar, I should have the same percentages each time. So instead of having 20 grams, now I'm going to say, well, what if I had 500 grams? And I found that I had 211 grams of carbon, 32.5 grams of hydrogen, and 256.5 grams of oxygen, and figure out the percentage. Now they should be, if it is the same sugar, they should be the same percentages. So let's see. 211 divided by 500 is, oh, look at that, 42% carbon. 32.5 out of 500 is 6.5% hydrogen. 256.5 out of 500 is 51.3% oxygen. So if I wasn't sure if this was the same type of sugar, then now I know it is. Okay, it's the same percentages as above. Even though my total mass is different, it doesn't matter. It's the same percentage of all of my elements. So that means that these are the same compound. Meaning this one here and that one up there. They are the same compound, same percentages. Law of definite proportions. Okay, the second law we're going to look at is the law of multiple proportions. And what that means is I can have now the same elements combined together, but in different proportions. So this is the same two elements or more elements, okay, can combine in different amounts to make different compounds. Now we're talking about different percentages, okay? So you no longer had the same percentage of the elements. For example, I said CH4 earlier, 1 carbon to 4 hydrogens. Well, carbon and hydrogen can make many combinations together. You could have C2H2, which is 2 carbons for every 2 hydrogens. So notice how I have the same 2 elements, carbon and hydrogen, in different proportions. But that means that these 2 compounds are different. They are not the same thing, okay? These are different compounds. But this law is what makes it possible to have many, many, many different compounds with the same combinations of elements. So let's look at an example. Okay, flip over that paper you have, and it says for each compound in the table, fill in the ratio of the mass of oxygen to the mass of hydrogen. And so the first one they give me H2O. Okay, so I've got 16 grams to 2 grams. So that means the mass of O to H is the same as 8 to 1. 16 to 2, the same thing as 8 to 1. Okay, now I've got H2O2. I've got 32 grams of O to 2 grams of H. So that's 16 to 1. So now you've got twice, okay, the amount of O to H. So then the question below asks, are H2O and H2O2 the same sample? No. Okay, one has twice as much oxygen to hydrogen as the other. Okay, in order to be the same thing, they would have had to have had the same mass of O to mass to H ratio. So if I had another compound down here, say this was compound X, I didn't know what it was, and they told me that it was, let's go, 32 grams to 4 grams. Well, now we're saying, okay, 32 divided by 4 is 8, it's 8 to 1. Then that would mean that this compound here has to be H2O because it's the same ratio as this one up here. Okay, so many elements can combine in different amounts. That makes my multiple proportions. If they are together in the same amount, that means I have the same compound, law of definite proportions.